Yeah, good evening, good afternoon, depending on where you are watching me from. Yeah, tonight we are going to look at Picard's method of, excuse me, successful approximation. Here we have a question. Employ Picard's method to find a solution of dy over dx equals to 1 plus xy up to third approximation with y of 0 equals to 0 is simple as ABC. So tonight we are going to discuss about Picard. It's not difficult, it's just how to iterate. It's all about iteration. Is that clear? So I'm going to break it down for you, but what you help me do tonight, please, I want you to like, share, comment. Thank you and God bless you. Okay, yeah. Here is a question. But before we look at this question, let us define Picard mathematically. Since Picard has to do with iteration, so the mathematical definition of Picard is given as, let's write solution, right, is y subscript n plus 1 is equals to y subscript n plus integral x naught to x and f of x comma y subscript n dx. Amen. Yeah. Do you agree with me? Okay. So if you agree with me, you don't need a prophet to tell you. So this is the mathematical definition of what? Picard. Amen. Are you following? Okay. So let's look at it together. So what we need to do here is a first order differential equation. So it means this f of x comma y naught is the function. This is 1 plus xy. Do you agree with me? Please listen attentively. Look at the board very well. Look at the board very well. Is that clear? So if you agree with me, it means what we need to do here, So what we need to do here is we are going to substitute in this function here. Is that clear? So we'll substitute in this function here. So when we substitute in this function, here we are going to have y subscript n plus 1 is equals to y subscript n plus integral x naught to x. So this f of x comma y is going to be 1 plus xy subscript what? N dx, open bracket dx. Do you agree with me? This is how it's supposed to be. Any question, please? Do you have any question? Yes or no? No question. Please, I want you to like, share, and comment. I'll be very grateful. Okay. So let's look at it together here. Let's look at it together here. So now, since they said up to third approximation with y of 0 equals to 0. You know, this boundary value is supposed to be y of x equals to 0. So it means if we have y of 0 equals to 0, it means our x2 is 0 and y2 is also 0. Take note. Do you agree with me? Do you agree with me? Okay, so if you agree with me, that is that. Then we now, since it has to do with what? Iteration, so we putting n equals to 0 because they set up to top. So if n equals to 0, here will now be y0 plus 1 equals to y subscript 0 plus integral x naught x. Then here we are going to have 1 plus x y naught because our n is 0 dx. So as you can see, this is x naught. So x naught is 0. So now let's come back to the boundary condition. Y, x naught is 0, y is 0. Two of us. So here will be our y 0 plus 1 is 1, y1 is equals to y naught plus integral x naught is what? 0, right? Then to x, open bracket, 1 plus x times y naught is what? 0 times 0, close bracket, dx. So this implies that our x times 0 is 0. So this integral, this is how it will look like. Y is equals to y naught plus, okay, y naught 2 is 0, right? So here is supposed to be 0. Here is supposed to be 0. Yeah, here is supposed to be 0. So we are going to have integral 0 to x. Then here will be 1. 1 times dx is dx. So when you integrate this function, you are going to have x at 0 to what? X. So if you substitute or subtract the lower limit from the upper limit, it means our y is equals to what? X. This is what we are supposed to have because these are what? Definite integrals. Do you have any question? Please, if you have any question, ask before we proceed. Any question? Do you have any question? No question, right? So you mean we can proceed, right? Okay. So they said we should, let's clean here, up to third approximate. So if you can see what I am seeing here, let's look at it together here. So it means when putting n equals to 1, it means here will now be y subscript 1 plus 1, which is equals to, here will be y1 plus integral x naught to x, then this is what? Open bracket 1 plus x y1, right? Dx. Two of us. It's true, right? Okay. So if you agree with me, here will be what? 1 plus 1 is 2 equals to y1 plus, mind you, x naught. The boundary condition here is y is 0, that is y naught is 0, then x naught is 0. So here would be integral 0 to what? X, open bracket, 1 plus, this is 1, x1, so y1, true or false. So what is our y1? We come here, our y1 is what? X. So here would be x times x, open brackets, x times x, close this bracket, dx. So this times this, x squared, but mind you, here is x, true or false. So our y subscript 2 is equals to x plus integral 0 to what? X, then open bracket 1 plus x times x, x squared, dx. Do you agree with me? This is how you are going to evaluate the first iteration. Any question or is there any mistake? Look at it. Let's look at it together. If there is any mistake, just let me know. It's okay. I think we all are following. True or false? It's true, right? We all are following. Okay. So far, so good. Let's proceed to look at it together. So here we have to integrate and substitute in both the lower limit and the upper limit. Here will now be y naught is equals to x plus, if we integrate this, we are going to have x plus x raised to the powers of what? 3 all over 3, then close bracket at 0 to what? X naught. True or false? 0 to x naught. True or false? Look at the board very well. Any question? True or false? Look at the board very well. Am I right? Okay. So let's proceed. Let's proceed. So if I'm right, it means here we are going to have y subscript 2 is equals to x. Already this is 0. Anywhere you see is the same x. X plus x plus x raised to the powers of 3 all over what? 3. Honestly, we can add this to this to give us our y2 is equals to 2x plus x raised to the powers of 3 all over 3. Do you agree with me? So now what we need to do here is we have to put in y equals to 2 because up to third approximation. So putting n equals to 3. So we have to come back here. When we come back here, we are going to have y subscript n 3 plus 1. Oh, 2, sorry, not 3, 2, sorry. That's 2 plus 1, sorry. Then equals to, here will be 2, then plus integral x naught to x, and our f of what? X comma y to dx. True or false? Do you agree with me? So 2 plus this is 3 equals to y subscript 2 plus mind you, x naught is always 0. So here is 0, x, the f of x is this. So here will be 1 plus x, y subscript, then dx. True or false? Where we know that our, can I clean this? I can clean the hub, right? Where we know that, we know very well that our, okay, our y2 is this. True or false? So we substitute in this. So here will be y3 is equals to y2 is this 2x plus x raised to the power of 3 all over 3, then plus integral 0 to x, then open bracket 1 plus x times y2, which is 2x plus this. So x, open bracket 2x plus x raised to the power 3, open bracket, close bracket, dx. Right? So if you can see what I am saying, this is the same thing as 2x plus x raised to the power 3 all over 3 plus integral 0 to x, then open bracket 1 plus multiply out, we are going to have 2x squared plus x raised to the power of 4 all over 3 dx. Do you agree with me up to this level? You agree with me? True or false? Am I right? Am I right? Okay. So if you agree with me, I think I can clean here. I can clean here. So if you agree with me, this implies that, excuse me, you don't need a prophet to tell you. You don't need a prophet to tell you. Yeah. You don't need a prophet to tell you. Okay. So if you agree with me, here will now be y subscript 3 is equal to 2x plus x raised to the power of 3 all over 3 plus, if you integrate this, we are going to have x plus 2x raised to the power of 3 all over 3 plus x raised to the power 5 all over 5, sorry, all over 3 times 5 at 0 to what? X. True or false? This is how it's supposed to be. Y is equals to, well, we substitute, this is the same thing. We are going to have the same thing all over 3 plus x plus 2x raised to the power of 3 all over 3 plus x raised to the power 5 all over what? 15. Am I right? It means we can add this and this, we can also add this and this. So the final answer will be, I think we can add this and this, same time add this. Final answer will now be y subscript 3 is equals to 2x plus x is 3x, then plus x cubed all over 3 plus 2x cubed all over 3 is 3x cubed all over 3, then plus x raised to the power of 5 all over 15. Am I right? So at this point, we can conclude by saying this and this will go. So 3x plus x raised to the power of 3 plus x raised to the power of 5 all over what? 15. This is the final iteration. Do you have any question, please? If you have any question, ask. Drop it in the comment section. Any question, please? Okay, gentlemen and ladies, in absence of any other question, I wish you all the best. Thank you for your time. See you guys. Enjoy yourself. Bye. Good night. Please don't forget to share and like.